Today I have a plan to cover the dplyr package, right? Dplyr is one of the most popular package for data processing, right? So whenever you have maybe unstructured data or complex data, right, that doesn't have a proper structure, so what you have to do, we just have to structure and then we'll proceed further. Okay, so here I'll just input a few files and I'll show you how to apply that. So first of all, I guess I just have to change this path because right now we should have in D drive. Let me check. Yeah, so here we have the data sets, so I can assign this path. Okay, I'll also load this package, right? Read Excel. Why? Because I have to import this population file, right? And this population file is Excel file. That's why I'll have to install and load this read Excel package. And then here I'm just importing. So let me change the path here as well. At this location, we have this file as population. Okay, so I should now bring this file. Okay, so one thing what I can do, I can just clean because there are a whole lot of objects. So I can start from this line number 2nd. And here we have. So right now this Excel underscore data I just imported. Here we have total 12 variable and 483 observation. Okay, and here we'll show you how to create new variables, how to modify and all, right? And I also request if you are not speaking, so just mute. Okay, perfect. So here, and this is the structure of this data set. We have this is table, and then we have these 12 variables and their data type, and we also have few observation. Okay, so first thing is I'll show you how to install the dplyr using install.package function. So I have already installed, so maybe I can just do that. It will basically do the overwriting, right? It will overwrite on the previous package, right? So I can use install.package function, and inside this parenthesis and double or single quote, I can use dplyr. So let me run this. It'll take a few seconds. Yeah, so this is installed, and I can comment just to avoid the maybe downloading again and again, right? So I can just now load. Yeah, here we have. And if you notice, it is giving some kinds of message here, notifications, because there are some conflicts with the function, right? For example, this filter and lag. We also have these two functions in the stat package, right? So that's why it is saying that the package, when you load this dplyr package, so what it does, it will mask the functionality that is present in the stat function. That means it will basically override those functions that are available in both the packages. Okay. Similarly here, we have this set theory functions, for example, intersects, set difference, set equals, set union, right? These are the 4 functions that are also there in the base, but when you load this dplyr package, it will override, right? So this is the thing. But if you want to explicitly use this function, so you'll have to use this way. You'll have to write first package name, double colon, and that function. For example, like this stat, this is the package name. Then I'll have to use a double colon and then the filter function. So this is a more explicit way of using filter function from this stat package. Okay. But if we just use filter, it will basically use the functionality that is available, or use the function that is available from this dplyr package. Okay. So next is here we have bunch of function. First is select. This function is used to select or keep or drop variables. Then we have filter. As name suggests, so this function allow us to apply filter. For example, if you want to apply filter on safety population, so we can apply that. If you want to apply filter on ITT, PP, right? So you have to use a filter, then you have to use a proper variable name and filtering conditions. I'll show you how this works. Then the third is the pipe operator. This is special. So this allows us to do sequential operations without creating multiple data sets. So you can create, you can perform multiple various operation, right? Just on a single data frame. The third is arrange function, allow us to order or reorder the data, right? This is similar to proc sort. This mutate, this allow us to, this helps in creating new variables, right? Based on the column, whatever we have in the data sets. Then we have summarize function. This will help in creating a summary statistics. For example, you can create n count, mean, median, and other summary statistics measure. Then the group by statement. This will basically group the table, okay, based on some certain variable. And so I'll show you these function one by one. So first of all, we have two important function. One is call name, right? So what this does, it will basically extract the column name of a particular object. So these are the column name we have. Similarly, we can also use a names function. This too works in a similar fashion, right? So there should not be any difference. And if you notice, these two are giving the same answer. Okay, so we total have 12 variable, and these are the variable name. Okay, so next part is how to keep and drop variable using the select option or select function. So first of all, how we have to use this? So we'll have to first specify select, yeah, then here you'll have to specify the data frame name, and whatever the variable that you want to keep, okay, you'll have to specify after the comma, yeah, here. So if you notice, I'm just keeping 3 variables, so that's why I'll have to combine these 3 variables using the combine operator C. Okay, and this is the way how this works. So let me just rewrite again, and then I can just replicate the other thing. Okay, so you just have to use select, then data frame name. Data frame name is Excel underscore data. Yeah, so I can use Excel underscore data. Then what? Suppose I need just a single variable, a variable of DOB. So I can just write DOB. This is case sensitive language, so be careful while specifying or while writing the variable name. And if I run this, it will only keep a DOB here. Okay, so we just have single variable and 483 observation. Suppose I want to create a object out of that. So what I can do, I can use here df underscore new. So it will create here a new objects df underscore new, right? This is a data frame, that's why it is under the data section. And here we have 483 observation and single variable. Suppose I also want to keep the variable of age. Okay, so what I can do, I can age cal, right? So here we have the variable of age cal in years. So I'll have to specify a comma, and I can write here age cal underscore. Okay, but we cannot, so if we are specifying 2 variable, we just have to wrap these 2 together, otherwise it will not work, right? And so I'm using here a parenthesis just to wrap, and I also have to use a combine operator C, and this C should be in lowercase. And if I run this, now it will create it will keep both variable of DOB and variable of age years. Okay, and here if you notice, we have 2 variable. You just click here and it will open in the editor. Suppose I also want to keep the variable of site ID. So I can just write here comma, and I can use site. What is the name? Site name. So I can copy paste. This is also a way because we don't have a proper case of the variable. And suppose I also need this use subject ID. So I can paste, and this is the way how we can increase the number of variables. So it is doing two things. It is keeping the variable right from the data frame, and also it is maintaining the order. So if you notice, I specify first here as DOB, then age, then site name, and then subject ID, and it is preserving the same order, right? So if you compare with the SAS, it is basically doing the function of keep as well as retain. Okay, and retain in the sense of keeping the variable in a proper order. Okay, so this is the functionality. So there are multiple ways how we can utilize this select function. So we can have here some other option. I'll show you. So suppose I want to drop. So what I have to do? I just have to put a minus symbol, and it will basically drop these variables that are specified under this combine operator C. Suppose you want to drop a single variable, you just have to write the variable name, and prior to that, you'll have to use a negative symbol, right? So it will drop that single variable. If you want to drop multiple variables, you just have to wrap all the variables inside the parentheses, and then you can use a minus symbol. So it will drop all the variables from this data frame. Okay, and this line number 30 is same as maybe here. I just kept this different variable name, right? You can run and you can check. So for example, here, if you notice, we don't have the variable of race, we don't have the variable of DOB, and also safety and efficacy population, because I dropped these 4 variables from this data frame. Okay, so this is the way. Then next is we also have some nice function where you don't have to write the variable name. It will basically use certain patterns, and based on that, it will keep an order of variable. Okay, so for example, I want to keep all the variable that starts with capital S, right? So it will basically check all the variable name, and whenever we have capital S, it will preserve or it will keep. So you can use this start with, you can use end with, you can use contain, or you can use the combination of right, these multiple function. Okay, so this is the way. Suppose you want to keep all the variable at end with pop, so you can do that. You just have to write end underscore with, and then inside the parentheses, inside the quote, you'll have to use pop. Okay, then again, you can use contain, and you'll have to use underscore, so it will preserve that as well. Okay, it will preserve all the variable where we have underscore, okay, at any location. So start with, it will basically search capital S or whatever the thing that will specify here at the beginning. End with, it will search this text at the end of the variable name, and contains, so it if contains is available at any position, right, it will try to keep that. But these are very specific. It will either work if S is at the beginning or pop is at the end. Otherwise, it will not work, right? But contains is more general. Okay, and here we can use a combination of all. Okay, so this is all about the select function. I'll pause here. Any question?
Yeah, I have a question. So the
Yeah, please.
line 32, 33, and 34, can you put them together, like combined, or do they have to be on separate lines if you're trying to make the same statement?
Okay, so here I combine, right? Start with S and end with pop. So you just have to use combine operator and you can combine this. Okay?
Okay, so if they're on separate lines as well, does it work the same, or does it have to be combined on the same line?
Yeah, so it can be at a different line, but you'll have to combine with this combine operator C. So this is very important. It can be in the next line, right? But you'll have to combine.
Okay.
With the combine operator C, yeah.
Okay.
Because once you not specify the wrapper, I'll not consider these as an argument. Okay, whenever we have multiple arguments, you'll have to always use the combine operator C. Okay. Yeah. Perfect. Any follow-up question, anybody?
Hi, Ranjit.
Yeah, please.
Yeah, they will it R recognize only pop and yes, or we can specify anything like FL ends with
you can specify like anything.
Flags and
you can specify anything, because why I use pop, because in my data says we have 2 variable that ends with pop, right? That's why I use that. You can use anything. This is just text. Whatever the text you will specify, it will basically keep.
Okay, thank you.
Perfect. Any follow-up question, anybody? Okay. The next is the filter. This is very obvious function. It allows us to filter the data. Okay, for example, you have a data where we have subjects, right? Male subjects and female subjects. So you can apply a filter and you can select either female or male. Okay, you'll have a whole data where we have different categories of treatment. So you can use filter and you can choose treatment A or treatment B and whatever, right? So here we have. And how we have to apply the same thing, you just have to use filter. The first position is for the data frame. Okay, and next you'll have to apply the filter. So for example, I want to select the female subjects, so I can use the variable that have a male and female store, right? So we have here sex variable, and this is very important. So we'll have to always use a double equal. Double equal is for evaluation. So whenever you are applying any filter, so you'll have to use a double equal, right, for that. And suppose you want to apply a multiple filter, for example, female, race is equal to white, safety population is equal to Y. So you'll have to apply these conditions just one by one, following by the comma. Okay. So this is the thing, how this works. Okay, so this is these are just an example, but in a real setting, we'll not use this way. We'll use inside the pipe operator, right? So first of all, I'll show you what pipe means. So pipe, this is a symbol. You can use a shortcut key, Control Shift and M button for printing that, right? Just in one go, or you can just type %, then greater than symbol, and then %. And what this does, this is very elegant function. This allows us to do a sequential operation, right, without creating a multiple data frame. Okay, so what this means, for example, here, yeah, we also have a native R pipe that is built in R. So this is called a migrator R pipe. Yeah, and this was so we have a package migrator R, right? That migrator R package contains the functionality of this pipe, but when you load or install dplyr, it will basically bring that migrator R pipe, okay, as a default. But this is called a native R pipe, where we have a symbol is this is a different symbol, vertical stroke, and then greater than symbol. This is a pipe that is part of a base R, right? So if we are using any R version that is after 4.1.1, so we'll have that native R pipe, and for that you don't have to install any or load any packages. Okay, this is also efficient, but because we are using this migrator R pipe from so many years, right, that's why people use this, but we'll have to switch to a native R pipe because this is efficient, and here we don't have to load and install any additional packages. Okay, so these are the functionality. Okay, so let me show you one function here. Sorry, any question, anybody?
No, Ranjit, no question.
Yeah, sorry, because here I cannot see the chat, right? So sorry for that. Okay, if you have a question, yeah, you just have to unmute yourself. Yeah, that's great. That's perfect. Okay, so how can I apply the filter?
Ranjit, someone messaged Riaz, I think. He's messaging like he can't hear.
No, now it's resolved.
Okay, fine.
Okay. Thank you. Okay, perfect. Okay, so let me go to this studio. Okay, so suppose I want to first I want to filter a data frame. right? And over there, I'll have to filter only treatment A. So for example, in our param datasets, but I just imported Excel underscore data. So here we have a bunch of variables. So we have a variable of treatment, right? If you notice, we have a variable here, TRT. Suppose I want to filter only the data for TRTA. Okay, and the second thing is I also have to keep a certain variables. For example, I'll have to keep the variable of race and all other variable that is between height and treatment. Okay, so I'll have to keep the variable of height, BMI, weight, and treatment. So these 4, right? And also the variable of race. So these are the things I'll have to do, right? So how can I do just with the filter function? So any function works from inside to outside. So first of all, here we'll have to use filter. Then inside that, I can use select function, and I can just select the variable that I need. So I need the variable of race and the variable of height, weight, BMI, and treatment. So what I can do, because these are in continuum, so I don't have to specify all variable, right, one by one. I can use colon. And what this does, it will keep all the variables starting from this height underscore CM to treatment, and it will additionally keep the variable of race. Okay, so here, if you don't specify this combine operator, this works, there is no issue. But the recommended structure is whenever you are specifying more than one object, so try to wrap all in a combine operator. Okay, so this is the filters. This is not filter, this is a select. So it will basically keep these variables, 5 variables. Then after that, I'll have to use comma because this function is complete. And then I'll have to specify TRT is equal to TRTA. So this is the variable name, and this is the label I'm filtering. Okay, and if you notice, this is a slightly complex structure. Suppose I want to perform 5 operation, so it will be even complex, right? So that's why we generally don't use this way, right, of filtering and selecting the variable. We'll use a different way. So what I'll do, I can simplify that step. First of all, I can create a data frame, Excel underscore 1, and where I'll just apply a single function, select, right? So it will basically choose the variable, right, these variables, and I'll store here in Excel underscore 1. And then I can apply a filter of treatment on this new data frame, Excel underscore 1. So I'm just calling here, and then I'm applying treatment is equal to TRTA. TRT is equal to TRTA. Okay, so this is okay, there is no issue, but the problem here is we'll have to create a 2 data frame. Suppose you will have to perform maybe 8 operations. So in that case, you'll have to create 8 data frame, and that is not efficient, right? Because if you create any objects, it will basically store in your RAM and it will occupy the RAM space. Okay, if you're working with a very large objects, so these are not an efficient way. So what is the efficient way? Efficient way is just to utilize the functionality of pipe. So here, this is the way how we can use. So we'll have to first use the data frame name. Okay, so what this does, it will basically bring this data. Then I'm applying pipe. Okay, and then here I'm applying a select statement. So what this does, it will bring this data and then apply the select statement. It will basically keep these variable. Again, I have pipe. So on top of that, right, after selecting the variables, it'll do this filtering. It will do the filtering of treatment, right? Then here I'm summarizing by race. So I'm basically evaluating the race count, right? So here this is a group by statement because I have to evaluate the race count for all the possible races that are available in the data, right? And here, this is a summarized statement. So it will basically evaluate the n count based on the variable of race. Okay, so if you notice how many operation I performed, 1, then 2, 3, and 4. So, and here we don't have to create a multiple data frame. So everything is done based on this Excel underscore data. And how it performs, so it will work from top to down. Okay, so it will apply it will select the variables, then apply the filter, then apply group by statement, and then at the end we have a summarize statement. Okay, and this is efficient. Why? Because we don't have to create a multiple data frame. It can perform all in one operation, all in one data frame, right? And here we have the count based on the data set that I'm using here. Okay, so this is the way how pipe works. Any question? Anybody?
So Ranjit, so we don't need to use the combine when we were selecting the columns here.
If you don't use also, it will work. There is no issue, but I recommend try to wrap those, because sometimes you miss and it'll give error, right? So I recommend just use the combine operator whenever you have more than one object, more than one column or a thing that you are combining. Okay.
When we use the pipe also.
Correct.
Okay. So here you were not using C, right?
I'm not using C because yeah. So this works. There is no issue, but I recommend. So let me use that.
Okay.
Ranjit, this is Riyaz.
Yeah, please.
Yeah, like here you use the summarize option, right? Function is function or option?
This is a function.
Summarize.
We'll discuss this function right in a minute.
But like in brief, like what it will do? Like,
yeah, this will basically summarize. It will evaluate n count, mean count, right? Mean, median, right? So if you notice here on the right hand side, we have this n with parenthesis function. So I'll just revisit this example function again, right? Summarize and this n.
Okay.
So it will evaluate the n count basically. Okay, the next is creation of new variables. So you'll have to use a mutate functionality and you can create a new variable. For example, here we have Excel underscore data. This is our main data. And then here, if you notice, we don't have the use subject ID. So what I can do, I can combine this site and subject ID together and I can create a new. And how we have to combine? So just recall the paste function or paste 0 function. So here, I just have to write this data frame name, then pipe, then here mutate, yeah, and then you have to use subject ID. So this is the new variable I'm creating. And then after equal symbol, I'll have to use appropriate function for combining the variable. So here I have to combine site name and subject ID together. So I'll have to use here paste 0, and I'm specifying a separator as a hyphen. Okay, so this is one thing. Then other are I'm also converting these 4 variables into a numeric data type, right? Age underscore num, height underscore num, weight underscore num, and BM underscore num, right? So these are the new variable I'm creating based on these operations. So let me run and show you. So we have here pop data, right? And if you go far right, we should have the variables. So use subject ID, age num, height num, BMI, and weight and BMI, right? And all are in numeric data frame. Why I converted that in numeric? Because I can show you how to evaluate the summary statistics. Because the other variable, right, that was there in the data frame, these are not a numeric. These are a character variable. Okay. So this is the way how we can convert. And then the next part is I can drop the redundant variable. Okay, and I can keep the one that I need. Okay, so if you notice, when I'm creating these variables, I just use strategically suffix as num. What I can do, I can utilize this end with num, right, for keeping all 4 variable along with the use subject ID and treatment. Okay, so whenever you are creating anything, right, so try to create, right, and just think in low time preferences, thinking in future, right, how you can create the variable so that you don't have to, you can apply the keep and drop function, right, efficiently. So here we have the pop data, okay, where we have all 6 variables and 483 observation. Okay, so this is the functionality of mutate. So mutate is way of creating additional or new variable, right? And what this does, it will keep a new variable based on the old variable that are present in the data frame, and it will preserve old and new together. Okay, but sometimes we'll have to create a new variable based on some old variable that are present in the data, and we don't need the old variable anymore, right? So if you want to do that functionality, so for that we have here a function transmute. Okay, and we'll only keep the new variable that you're creating, and will drop all the existing variable from the data frame. Okay, so here I'm again using pop, so this data, and I'm just standardizing the variable. For example, here we have age. So these are the numeric value for individual patients. What I can do, I can evaluate the mean of this. So I can evaluate mean of this age. Pop dollar symbol.
So what does the pop do?
Sorry,
what does the pop do? So in the previous statements, you were assigning
line
the
number?
data to 66.
Okay, 60. So this is basically I'm just performing this operation. I'm storing this thing here in the pop data frame. Yes, this is the way how this works.
So when we go to the output, do we have a column for pop?
Pop is not a column. Pop is an object. Pop is a data frame. These are the column of your subject ID, age, now, right?
Yeah, those are the.
These are the column or variable, but this is the data frame. If you notice here, this is the pop. Pop is there here, and here we have a bunch of variables.
Okay, pop is the data set name, right?
Correct. Yeah, and variable names should be there inside the mutate.
Okay.
Yeah. Okay. So, any follow-up question, anybody?
Hi, Ranjit. In at the line 61, group by is acting like a grouping variable.
Correct. This is a grouping variable.
And we are summarizing later on for the count, whatever the summary statistics.
Correct.
Thank you.
Okay, give me a second. Okay, sorry. So here pop is a data frame, and these are the variable or column name, right? So this is the thing. Sometimes we don't have to keep the old variable. So for that we have option transmute, and what this does, it will only keep the variable that you're creating in the current session. For example, what I can do, I can standardize the data. So standardization means you just have to subtract the mean from the individual values. That means here we have the column of age that is present inside this pop data frame, right? And I can use any dot is equal to true, and I can evaluate the mean. So mean is 48.88285, right? And here what I can do, I can subtract this 48.88285 from all the values one by one, right? And that is called standardization. But here you can do that in one go. So you'll have to use age underscore std. So this is the new variable I'm creating, right? And here this is the variable that is present in the pop, and this is the mean. So I'm subtracting mean from the original variable. So it will subtract from all 483 observations, right? And it will create altogether a new variable, age underscore std. STD is a notation for standardization. Why this is important? Because sometimes we'll have to standardize so that we can transform in a better way. So, right, so we should have proper distribution, right? And we can very easily evaluate the testing procedure, right? Sometimes we'll have to do the outlier testing, right? So you can transform and then you can compare very easily. So here I'm just subtracting the mean. Sometimes we also have to divide this whole quantity by a standard deviation of this age underscore norm variable, right? And that is a more sophisticated kind of transformation. Okay, so here you're just subtracting mean. This is basically a shifting origin, because once you subtract the mean, the values should be of a lower magnitude. So let me show you. So the main thing is, so when you use transmute, it will basically keep the variable that you're creating and it will drop all the variables that are present in the data says pop, right? So here I'm using pop, so that's why it will drop all the variables and will only keep a single variable age underscore std. And if you notice, it just have single variable and these are the values, right? And if you notice, values are of a lower magnitude. Whereas if I compare this pop, right, so age is having a very big values, right? 57, 56. And why we have a lower magnitude? Because we subtracted the mean. This is very obvious. Okay, so transmute keep only the variable that you are creating at the particular step, right? It will not keep the variable that are present already in the data set. Okay. Okay, so next is arrange function. This is basically a sorting, right? So you can use here arrange, and then you can specify the variable. Suppose you want to sort a particular variable in descending order, right? So you'll have to use DESC. DESC is for descending, and then you can specify the variable inside that. And the second variable, if you notice, I'm not using any descending here, so this will sort in this with ascending functionality. Okay, and here, please go ahead.
In at line number 72, we are making a data frame. We are creating a data frame with a mutate function, right? So we are creating new variables. But what if already whatever the variables we have, we want those variables also, and at a time we need new variables to be created. So will this same function work?
Yeah. So here mutate I used. Mutate is basically for creating additional variable, and when you use mutate, it will create new variables and will also preserve the variable that are there in the data frame, right? So for example, the variable of treatment. So here I use select, that's why it is keeping just 6 variable. But when I run this part without the select, when I just run this part, it will have total 17 variable. Why 17? Because in the parent dataset we were having 12, and here I created 4 additional variable. One is use subject ID, age num, height num, weight num, BMI num. So total additional 5 variable I created. That's why 5 plus 12, this is 17. But I don't need all, so that's why I use a select statement just to keep a required number of variable, right? So that's why I just keep 6 so that I can show you functionality and other thing. Okay.
Thank you.
Yeah, but when you use transmute, it will only keep the variable that are creating in that particular step. It will not preserve the other variable, use subject ID, and all that are present inside this pop data frame. Okay.
Okay. Thank you.
Yeah. Okay. So next sorting here I just showed. Okay. So we also have some other functionality. For example, we have a function of case underscore when across, distinct, row wise, and group wise. So let me write here a comment. So case when this works in same fashion as if else, right? So whenever, suppose you have a numeric variable and you have to assign a categories based on that, so you can use case when. Okay, so this is similar to. Then we have across. So sometimes we'll have to perform our operation on multiple variables, right? So here comes the across. It can perform the variable in a column-wise fashion, right? And multiple variable. For example, you'll have to, so maybe you can think of array statement, what we have in SAS, right? So array allows us to perform operation on multiple variables in one go. Similarly, the across, this does the same thing. For example, you have to evaluate the summary statistics and mean, median, standard deviation for the column of age. And you'll have to do again the same thing for the column of height, weight. So you'll have to replicate the code chunk again and again, or you can use just a cross function and you can perform the operation, right? Okay, in one go. Then distinct, this is removal of duplicate. And row wise, sometimes we'll have to perform the operation in a row wise fashion, right? By default, R perform all the operation in a column wise way. What this means, for example, you can think of this as a population. So when I perform anything, for example, when I use mean option, so it will evaluate the mean of a column, right? Then mean of another column. So it perform the operation in a column wise way. This is a default or inherent structure, but sometimes we'll have to perform the operation in a row wise. I'll show you the example. So we'll have to use this row wise function, and then you can perform the operation in a row wise way. Group wise, this is basically for grouping the data. Okay, so let me cover these functions one by one. So this is the data frame I'll use, right? So here we have a variable of BMI, right? Suppose I want to convert the BMI based on the categories. For example, underweight, healthy weight, overweight, and obese, right? And here we have the rule. For example, if somebody is less than 18.5, so that is fall under the categories of underweight. So between 18.5 to 24.99, it should be under healthy weight. Then 25 to 29.99, this is under overweight or obese, right? And overweight. And 30 or above, it should be under obese, right? And here, how we have to create? So we'll have to use, again, we'll have to call this data frame pop, then pipe operator. Here we have to use mutate because we are creating new variable. The variable name I'm keeping here as BMI underscore category. And then I can use equal symbol and case when statement. Okay. So whenever you write the case when, so here we'll have to use the original variable. Based on that, you'll have to apply the filter, right? So here I have created already the BMI underscore num, and then I can specify the first conditions. So BMI less than 18.5, this is called underweight. So you have to use this symbol, tilde symbol, or this is called function symbol in R, right? And then you can specify the category that you want to specify, okay, based on this rule. Then the second thing is I also have to use other condition. So for that, I can use comma, and then I can write the new condition. If you notice the second one, here we have a two end. One is 80.5 and second is 24.99. So here I have to use BMI underscore num greater than or equal to 18.5, and I'll have to use ampersand BMI less than or equal to 24.99. And then it should be under healthy weight. And then again, the third one is overweight and obese. Okay, so this is the way how this works. And if you notice, we have here the pop1 data, and we have this last variable BMI underscore categories, and here we have. Okay, so this is the way how we can perform the operation. And this case when is the function that is a part of a dplyr package. Okay. Sometimes we'll have to create also the proper label. For example, in the data frame, we have the variable in the form of M and F. Okay, so do we have that? Yeah, here in the Excel underscore data, we have the gender information in the form of M and F. So I'll have to write as a complete label, for example, female, right, and male. And I also have to present some ordering variables. So what I can do, I can just write, I can use either prefix or suffix as a or one underscore, right? So that I can utilize this prefix, right, for the sorting purposes, and I can report the label, right, in the table, because in the table we don't need a underscore or one underscore. So that's why I'm creating here the label in this way so that I can also utilize for the sorting purposes. So we can create that part very easily. And here I'm creating a new variable as x1. Okay, so let me just run this part. Okay, so here comes this pop1 data, right? If you go far right, so here we have the variable of x1 where we have the ordering variable along with the complete label. So first thing is we'll have to separate these, and here comes the string R package. Okay, you'll have to install and load. So I already installed, so I'll just load this function package, and here I will have to use a function for extracting the number. Okay, so here if you notice the first let me show you the structure, the unique, so that I can yeah, so this is a pop1 and I'm extracting the variable that I just created. So if you notice, we have three things. One is 1_ female, second is 2_ male, and then NA. And then here I'm applying this str_sub. So what this does, it will basically extract the part of this whole thing. And here I'm using sex1 variable and starting position as 1, ending position at 1. So I need this number, right? So this is the start and this is again the end position. So that's why at both end, right, at both statement I'll have to use 1 1, right? And then it should give the data or should give the result in terms of a character vector. So that's why I'll have to use as.numeric to convert that in a numeric data frame. Okay, and here I'm just converting this whole thing, and then I'm storing with the variable name ODR. Okay, and next thing is I also have to create another variable where I'll keep just a label, right? This female and male, because when you do the reporting, you don't have to report 1_ or 2_. So I'll have to create another variable. Maybe you can use x2, and here I can use this again, the same function str_sub, that is a part of a string R package. And here I can use the variable where I created 1_. And then the most important part is how we have to specify the start and end position. So here, if you notice, this is the first position, the second is for underscore, and third is right. Third is the position where actual label starts, right? In the case of female. Again here, this is again the same thing. 1 is number, 2 is underscore, and 3 is the position where actual label starts, right? So what I can do, I can specify start is equal to 3, and I don't want to specify the end. Why? Because these two have different lengths. So if you don't specify the end position, it will basically extract till the end, right? And this is the way how we can process the data in a better way. And here we have the pop1 data, right? If you notice, we have ordering, and we have again the proper label. If you want to skip this ODR variable creation, you can do that, because you can also use this sex1 variable for the sorting purposes. Okay, because but I just want to showcase these two together, so that's why I use. And then I can use ODR variable for the sorting purposes, just to keep that in a proper way. Okay, and if I show you this now, so basically sort, and here first we have female, and then male we should have at the bottom. Okay, so this is all about the case when statement. Any question? Yeah, please.
Hello.
Yeah.
Whether can we use the fact.factor for this purpose?
Sorry, which function?
I'm not sure whether that function is there. Like factor function is there, no? Like numeric.
No, factor is altogether different thing. Factor is just to specify the label in a proper way, right? You don't have to use here the factor. We are not establishing any kinds of preferences, right, for the ordering. We are basically doing, we are basically extracting or adding some prefix here, right, just to sort in a proper way. Okay, and then we are extracting that. Okay.
Okay, we don't want to use for sorting also.
So sorting, we can utilize that for the sorting, right? We can utilize the variable where we have 1_, 2_, right, for the sorting very easily. But I just want to showcase, right, the creation of ODR, right? That's why I just covered. you can also use this single variable for the sorting.
Okay. Thank
Yeah.
you.
Yeah, Ranjit, small question. Like
Please.
in 109 line number, like we are using the tilde symbol, right? So in the case, like in the filter condition, so what it will do, like what it means actually.
Yes. So basically, what you're doing, you're just filtering this sex is equal to female. F, right?
Yeah.
Sex is equal to F, and then you're assigning this whole thing to 1_female. So what this does, it will basically store this 1_female for all the records where we have F in the sex variable, and will preserve this 1_female in this variable sex1. Right, so it is basically a kind of assignment you are doing, right, for filtering a specific record. Based on this condition. Yeah, perfect.
So hi, sir. So instead of like extracting like using str_sub option, can we use if else statement as well for assigning the like sex, and for this like if else statement we can use?
You can use if else statement here, case when, but you don't have to use here, because here we are not assigning anything. We are just extracting a part of the information from the variable, right? So here we can very well use if else. I guess we should have somewhere. No, we should. I guess I already covered this if else. So here we should not have.
In case and we can use if else in
Obviously you can use very well, but there is a catch, right? If else, if you are using a base if else, that is not efficient, right? And that have a complex structure. For example, you have to apply 20 conditions. So that will be even complex, right? Because you'll have to use nested if else. But the case when is very neat and clean, because here you can notice you should have a 20 line, right? But you don't have to use the parentheses, right? At every line, at the end of every line. So you just have to use the parentheses or closer at the very end, right? And you can embed here any number of lines. So this case when is having simple structure, and this is efficient because this is coming from this dplyr package, right? So this
is there any options like in we use in proc SQL, like in case statement when this and then this? So is there any option for when?
We also have SQLDF package. Maybe you can explore. I'll try. Maybe I'll try to cover some part at the very end of the course. Okay, SQLDF is one of the packages that is present in R. It's very useful for package that will mimic the functionality of proc SQL.
Okay. Thank you.
Okay.
Hi, Ranjit.
Yeah, please.
Case when sex equals to F, we are creating like 1_female, right? So instead of creating one like ordering, like sorting variable, and then extracting that and then giving the order and all, instead of doing all those, directly can't we give sex equals to F, then the numeric sex n equals to 1?
Yeah, you can create two variables, right? You're saying for creating two variables. Is that correct?
Yes, character.
Yeah, you can do that. Yeah, you can do that, but people generally prefer the recommended way is you don't have to use a whole lot of if else in your code. If you're using that, this is additional thing at the very beginning you can use, but
not if then case when only.
Yeah, case when. So I'm just saying here, so we should avoid just a structure, for example, a structure like case when, structure like if else. You should use some method, some function where you don't have to pinpoint the data. Why? Because there might be the case the data may change after some time, right? And if you run your code, it fails. So that's why people prefer the code, for example, str_sub or some other way, right? Why people prefer format? Because they don't have to go inside their code and they don't have to change. But if we use if else or case when statement, what you are doing, you're just basically choosing a particular label, right? For example, in the next update of this data, this become small f. So this fails, right? You'll have to use some other way of filtering that, right? So that's why this functional way of extracting and functional way of maybe specifying or maybe subsetting the variable is more appropriate. Okay, rather than just using if, else, and case when. But anyhow, if you don't have any other option, you'll have to use. But try to limit that use, right? So this is one suggestion. Hope this makes sense.
Yeah, thank you.
Yeah, okay. Yeah, you can do that. Here we can create a new variable. Yeah, please. Sorry.
Yeah. So instead of like character to character, can we do like directly to numeric, like F is we are like in text.
Yeah. You just have to remove this quotation and you can add the values.
So no need of extraction in the second step, like
but you'll have to also, I already told that we need to present in the table in this way, female and male. You don't have to present F and M, right? So for that, you'll have to create.
Okay. We are creating two separate one. Okay.
Yeah.
Thank you.
Okay. Any last minute question? Anybody?
Ranjit, sorry.
Yeah, please.
See, let us say like we are doing dynamic code. The second one is efficient, like mutate order as numeric str sub. Great. So here we are extracting start one, end one, right? Start one, end one are referring again to one underscore female.
Particular yeah. But here, if you notice, whenever you have you design the variable in a particular way, right? So because you are designing, right, it does not depend on the other person, right? So you can do that. Here we can also use some standard way. For example, you can use length, right? You can extract the length of the variable, and then you can just subtract or you can very easily do, but because I know that here I'm just defining the variable, defining the label in a proper way, right? So that's why I can use one, and I can very easily extract. But this is also not recommended. You just have to use a length, right? So there is a function length, and you can just write, for example, I can use so I can pass the variable and it will basically count how many character we have inside that particular variable, and you can use that, okay, as a statement.
So I understand, like instead of giving start one and end one, we should use dynamically like length.
Yeah, whenever possible.
Whenever is possible, there, it will pop up here.
Yeah. Whenever possible. So we'll also have to check. So, okay.
So we are not going to use both at a time, right? We are using only efficient way str sub.
Yeah.
Thank you.
Okay, so let's show you the summarize statement. So summarize, as name suggests, this allows us to do a summary statistics calculation, right? And here we can perform any number of summary statistics. For example, here I'm performing n count. So here we have function n with parentheses. So this is a very efficient function. This is built in R, right? And using that, we can evaluate the n count. So I'm converting that, I'm evaluating that n count, and then I'm converting that whole thing as a character data frame, a character variable. That's why I'm using as dot character. And I'm storing this whole thing with the name n. So let me just show you here some small structure, and then I'll replicate. Okay, so here I can use summarize, and I can use sub underscore cnt, and I can use n with parentheses. So what this does, it will basically evaluate the subject count for us, and it will store here in this data frame DES. DES is here, and here we have subject count 483. Suppose I want to segregate this by a group variable. For example, I want to group this whole thing by a treatment variable, so I can use a group by statement. Sorry. And now it will give the count for treatment A, count for treatment B. Okay, so here we have treatment A 260, treatment B 223. Okay. Similarly, suppose I also have to, so maybe I can convert this whole thing into a character data frame using as.character function. Yeah, and now this is in character data frame. Notice Second thing is I can evaluate other summary statistics. For example, I want to evaluate here mean, so I can use mean underscore age, and I can specify the variable age underscore num. Right, so let me just show you this functionality. So this will fail. Why? Because mean, the variable of age, has NA, so that's why it fails, and that's why it is giving NA here. So what I can do additionally, I can add another structure. I already cover na.rm is equal to true. So what this does, it will basically suppress the NA, and it will evaluate the mean for non-missing observations. So if I run this, here we have, right, this is the value for mean under the treatment arm A, and this is the mean for treatment B. Okay, so difference here is whenever you're using n with parentheses, you don't have to specify the variable name. Why? Because it performs based on this data frame that you're passing. But whenever you're using other function, for example, mean, median, standard deviation, whatever, you'll have to specify the variable name. Okay, so this is the structure. And then here we can have another structure, another thing, right? So let me just add this whole part. I can just delete this, and then I can, okay, hopefully this works. Let me run. Yeah, so this is descriptive. Now we have subject count, age, summary, mean age, standard deviation of age, median, again mean height, and mean weight. Sorry, standard deviation of weight. Okay, so if you notice here from beginning to this lines, I just evaluated the column of age. The next two line, right, last two line is for the height variable, right? So height, this is the mean height, this is the standard deviation of a height. Okay, but here, for example, for two variables, right, so we have these many things that we have to write. So this is not efficient. So what we can do, we can perform and we can utilize now the cross function. Okay, a cross function. So let me do that. So before that, here I want to again cover this statement na.rm. So for example, this is the num variable where we have these values, and we also have na at the end. I can use mean, and na.rm is equal to true, so it will basically suppress the na and then evaluate the mean of first three non-missing observation. Okay, so across, how it performs the same function on multiple variables. So we'll have to specify here the calls. So we'll have to specify the column name, and we also have to specify .fns, that is a function. So let me show you how this works. For example, let me write that. So I can use summarize. So across function works inside the summary statement, right? So inside the summarize statement. So let's write summarize, then you can write across. Okay, and here we'll have to use functionality dot calls. Sorry, not column dot calls, and here we'll have to specify the column where you have to evaluate the functionalities. For example, I want to use age underscore num and height underscore num, right? So these are the two columns where I have to do the summary statistic evaluation. And which summary statistic evaluation I have to do? I can perform maybe mean. So let me just do one summary statistic here, and I can use na.rm is equal to true, just to avoid right, evaluation of missing values, right? Whenever you don't use na.rm, it will basically throw an na, right, at the result. So I don't want to do that. So that's why I'm using na.rm is equal to true. And here I'm storing this whole thing with the data frame name des. So if I run this, it will basically create des, and you can notice we just have a summary of a height, right? And here we have the mean. Okay, yeah, so mean of height, sorry, mean of age and mean of height. So if you notice, age underscore num, this is the variable it is speaking, but here it is evaluating the mean. Again, this is again the mean of a height variable. So this is not a proper variable name creation, so I'll do that, how to update the variable name. So this is the way. Suppose I want to add another variable, for example, BMI. So I can add that. Suppose weight. and it will now perform the summary statistics mean for all 4 variable in one go. Yeah, so here we have. So this is most efficient function, right? You don't have to write this whole code chunk, right? Very big code chunk. You can perform this all operation in one go. The next important part is, suppose I want to perform multiple functions. So here you can add the function one by one. For example, I will need mean, median, then minimum, maximum, right? Or we can add other thing also. You can add here, and now it will perform all one by one. Oh, sorry. Am I missing anything? I'll have to use comma. Perfect. So now here we have, and based on the functionality, it will create a variable with suffix _1, _2, _3, and so on, right? So here first is mean, then median, then minimum, and maximum. We have 4 function, right? So that's why it is creating age _num _1, age _num _2, _3, _4. So first is for mean, second is for median, third is for minimum, and fourth is for maximum. And similarly for the height, weight, and BMI. Okay, all other column. Yeah, so maybe you can just check here. You can also use contains num, so it will pick all the variable in one go and evaluate. You can also use in with num, right? So it will just run and just verify. Then there is another structure. You don't have to specify this .col and .fns. You just have to specify the variable directly, and then here you can use this structure tilde symbol, the mean .x, and any.rm is equal to row. This is a recent structure, right? How this works. So they just updated that part, right? So you can use this way also, and you can perform the sorry, here I guess we should not have this column. I guess I changed the variable name. That's why. Let me check, because this variable should not be there in the pop data frame. So if I use call name, yeah, so we don't have the variable name with this height _num. So we have here variable hgt _num. So I just have to change that. Okay, now this will work. There is no issue. Okay, it will evaluate. Then again, we can also use where is .numeric. It will choose all variable in one go, all the numeric variable, and can perform. But be careful. Sometimes it'll have also the some variable, for example, variable of gender that is stored in the form of 0 and 1. At that variable data type is numeric, so it will also evaluate that. Okay, sometimes we have a subject ID that is again a numeric data type, right? So it can also choose that column, right? And it can evaluate. But we'll have to be very careful, right? Because those summary does not make any sense, right? So you can just avoid. And again, if you want to do a rounding, so you just have to use another data frame, and you can do the rounding based on the functionality. Okay, suppose you need 2 decimal point, you can use round, and you can keep 2 here. It will just keep. Okay, I guess this is. I'll have to change hgt _num.
Ranjit, I have a question. So.
Yeah,
for the line 168, what does the .x represent?
Yeah, .x means it will basically, this is a way of giving instruction to R, and what this does, it will basically pull variable one by one and will evaluate. So this is just notational purposes, right? It will basically pick the variable one by one, whatever the variable that you will specify at the very beginning. Okay.
Okay.
Yeah.
Thank you. So this is similar to we create macro for creating the tables, like in case of instead of doing separately, we create macro for like height, weight, and BMI if we want to.
Yeah. So here we don't have macro. We will create function. I'll cover that part as I proceed. Right? We'll create function and. Mm-hmm.
Yeah, but in this step we can do it like in one step we can do like right.
Yeah.
Instead of going to if we want to give format for median to for BMI, if we want to give some format, then how to give in this step, like across?
Yeah, so you cannot perform that thing in across. You'll have to altogether create a new data frame.
Okay.
That's why here I created a new data frame where I'm just using this ESC, and then I'm applying this round function.
Okay. So on every variable we have to create, right?
Right.
Okay. Format. Okay.
You can also create a function for automating that part, but you don't have to. You'll have to altogether create a new data frame, and then you'll have to perform. Okay. The next thing is Anybody, any follow-up question? Anything? Okay, the next part is how to give a meaningful name, right? So here we can also use this list statement, right, for specifying the function, right? So for example, in the proc summary, if you remember, or proc means in SAS, right, we'll try to use output and out dataset name, and then n is equal to n, mean is equal to mean, standard deviation is equal to standard deviation, right? So here also we can perform the same thing. So whatever the thing that you are specifying at the very beginning, this is the variable name, this is the function. Again, the variable name function, you can give a different name as well. And then this is a very important functionality, dot names. So it will basically combine the function and variable name in a proper way, so that anybody can understand what a particular column is all about. Okay, for example, here I'm combining dot fn underscore dot call, right? So it will basically create the variable where it will pick the first as a function name and second as a column name, right? You can change that as well, right? So for example, here if I run this, I'll have this structure. If you notice, first is the function name, so that's why mean, age underscore num, this is a variable. Median, this is a function name, age underscore num, this is a variable, and so on, right? So this is the way how this creates the variable. You can change that. Suppose you want to add a TRT as maybe a prefix, so you can also add that using this paste 0 function. So let me show you. So descriptor 1-to-1. You notice I just added a dummy label TRT. So you can perform. Why I'm adding this TRT? Because if we have some label, you can use that, right, and you can keep the variable in a better way. Okay, so maybe you just practice, because here I also skipped some part. These are very similar and same, right? So you don't have to worry about that thing. Here comes a new thing. So here I'm creating a variable where I am also specifying space and off, right? So when you create this variable, this is not a proper variable name, but intentionally I created so that I can show you how to refine that. Okay, so suppose I want to call any variable. So here I'll have to write the data frame name, DAS13 $symbol, and then variable name. So here if you notice, every time we'll have to specify tick at the beginning and tick at the end, right, for calling that variable. And this is not efficient because you'll have to type tick, and this is not a variable, proper variable name. But this happens when you transpose the data and when somebody created the variable in this way. Okay, so the thing is, here we can use a janitor function for cleaning that. So what this does, I'll have to install. Okay, so here we have a function, a clean underscore name, that is a part of this janitor package, and this will basically add underscore, right, at the place of a space if we use none. There are other options too, so let me show you first. If you notice, it just replace the space with the underscore. If I show you the old variable name, right, over there we were having spaces. So if we use underscore, right, if you just replace the space with underscore, this is now a proper variable name, and you don't have to use a tick while calling a particular variable, right? So this is the speciality what we have under this janitor package. We also have other functionality. You just have to do here some mistake, and let me just remove everything. So it will throw all the functionality that is present inside the inside this clean names function. So here we have snake case, small camel, big camel, and all, right? So I don't recommend you all to use these complex structures. Try to use none, where you'll add just underscore at the place of a space. Okay. So these are the useful functionality. Okay, so then here again, one more structure, right? You can just check this is similar to the above one, right? Now what I'll do, I'll just showcase this functionality of a row while statement. Okay, so let me create this data frame. Here we have the data df. Okay, so if you notice df, where we have all three variables as a numeric variable, right? All var1, var2, all are numeric. So here also I can perform the operation. I can evaluate the mean df1. So in the same way, right, this is having the same structure. I'm selecting this using this where is dot numerics, so it will pick all the numeric variable in one go, and then I can perform that operation. The same way you can also use this df structure, right? And the inherent function is right here, is.na. So if we use that, what this does, it will basically create a string of true and false, right? And map all the nas as true. So here it is giving true. So let me show you this data first. So if you notice in the second variable at the row number 4, we have ns. That's why it is mapping true. Similarly, for the third variable, the row number 2 is na, and that's why here we have true. Okay, so this is the structure of right, how this performs. So if we negate that, so it will just do the opposite. It will map nas as false, right, and non-missing as true, right? So you can check. So if you notice at the very end, we were having na in the second column, but now it is mapping false, and all non-missing values it is mapping as true. So you can utilize these for counting purposes, right, in the across. Okay, so next is how to remove the duplicates from the data frame. So here, if you notice, we have three variables, var1, var2, var3. If you notice, the row number 1 and row number 3 is same, because row number 1 has 1, 1, 1 at all three position. Again, row number 3 again have 1, 1, 1 here. So this is the structure. If I apply the distinct, what this does, it will suppress and it will remove the one that is at the bottom, right? And here you'll have to use distinct, and you can specify the by variable, right? This is the same structure. You can remember proc sort, where you'll have to specify data, then by, then you'll have to specify by variable, right? Over there you'll have to apply a no duplicate. Here we don't have to use that because distinct function can do that thing, right? But here we have additional structure that is called keep underscore all is equal to true, and we'll keep all the variables. So what this additionally doing, right? So whenever you are specifying these two as a by variable, so there might be the case that in the data frame we may have other variable too, right? And for that, for keeping all other variable, you have to use keep underscore all is equal to true. Give me a second. Okay, so here df2, yeah, if you notice, we don't have the last row. Now we just have a 3 row. Okay, so similarly we can also use distinct underscore all, right? This is same as a duplicate, where you don't have to specify the variable because it uses all the variable. So whenever you are using distinct underscore all, you can ignore the variable name, but you'll have to specify comma and then keep underscore all. So it will apply the duplicate based on all the variables, and it will keep all the variable in the data frame. Okay, again here the group by statement once again. So here group by statement is just to grouping the thing or grouping the summary statistics, right? And at the bottom hand side we have the summarize statement. Okay, so you can check the difference. Let me just comment that summarize a group by statement. I'll do summary. Right here we have, if you notice df3, we just have a single summary. That means this is overall irrespective of treatment variable. But I can use that. I can activate that functionality, and now we'll have information for treatment A, summary for treatment A, and treatment B. So here we have summary for treatment A, and then again here a summary for treatment B. Okay. Then suppose I also have to evaluate the overall summary, right? Somebody can ask. So here we have treatment A, treatment B. What I can do, I can create altogether a new data frame, pop, where I'm just creating a variable TRT again, and then I'm replacing TRT A and TRT B with overall. So if I run this, so pop2, if I show you this pop2, we just have one label that is overall, right? This is again the same way we are setting in a different way so that we can have a summary for treatment A, treatment B, and overall in one go. And here I'm setting pop, right? This is our original data sets where we have treatment A and treatment B. Let me show you. Pop, if I show you the treatment variable, we should have treatment A and treatment B. If I show you the variable right of pop2, right, we just have overall. And then here I'm just combining these two dresses together. And if I show you this variable of this pop final, pop underscore final, we should have here treatment A, treatment B, and overall in one go, right? And now I can use this pop final, and I can pass that and evaluate the summary for treatment A, treatment B, and overall in one go. Here we have. So we will cover these kinds of things right once again when we do the part 2 of the course, right? So I'll pause here. Any question, anybody? So there is one more statement that is, I guess, row wise. Yeah, any question, anybody, before I go to the next part?
Okay, can we check the output for that overall, Ranjit?
Yeah, why not? So where it is, descriptive underscore all. Yeah, here we have. I don't have the n count. That's why I don't think you can able to validate. Right, let me add that. Yeah, so we can have other thing. Okay. This is the overall this statement A and statement B. You can do separate calculation. You can verify. Okay.
Okay.
Yeah. So how we have to do the separate calculation? You just have to change the data frame name. Here you can use first pop2, right? And then again you'll have to use pop, because pop is the data where we have treatment A and treatment B, and we'll try to check. Okay. Perfect. Anybody, any follow-up question? Okay, so here I'm creating again another data frame table, another table, and this is the ID. So you can think of these are 6 students and their writing score, reading score, math score, and science score. Okay, so we have here 4 variables. So suppose I want to evaluate the total or a mean, right, of each subject separately. So how we can perform here? We cannot use a sum function, right? Because if you use sum function, it will basically evaluate the summary for all 4 columns. Okay, because R basically perform the operation in a column-wise fashion. If I compare with the SAS, right, SAS perform the operation in a row-wise fashion. Okay, this is a default functionality, but here we can also have a way to just allow or maybe give instructions to R to perform operation in row-wise way. So we have here a row-wise statement. Okay, so you'll have to use here a row-wise with a parenthesis. You don't have to specify anything here inside this parenthesis, and then you can create mutate a new variable. You have to use total, and then I can use sum. So what this does, it will basically evaluate the sum for individual row 1 by 1. So it will evaluate row 1 up to row 6. And if I run this, here we have dd descriptive underscore dd, And if you notice, this is a summary. You can count very easily. This is 10 plus 20, that is 30, 30 plus 30, 60, plus 40, that is 100. Okay, similarly for others. But if I just remove that row wise statement, what this does, it will basically provide the sum of all the values. If I just use total is equal to sum, so it will provide the sum for all the values, whatever we have. If you notice 660, that means this is a sum of all the 6 rows and 4 variables. Okay, so we just have to embed the row wise inside that. We can also use another way, right? We can use a C across, right? So C across is a way of performing the operation in a column wise, right? So this is a column wise across. And here I can specify where is dot numeric. So if we, for example, here we just have 4 variables. So I can very easily write, but for example, you have 20 variables. So it is tedious just to write that, right? So you can first convert all in numeric, and then you can use where is dot numeric. So here also we'll have to be very careful so that the variable that you want to include here should be numeric, and all other variable that you don't want to include must be in a character or other data type, right? Otherwise it will also combine and we can evaluate the total, and it will give the same thing here, same answer. Okay, so you'll have to do that way. And here, whenever you're using just a sum function, you cannot use where is dot numeric. Okay, you'll have to always use C underscore across, and then you can use where is dot numeric. Okay, so this completes this session. I'll pause here. Any question, anybody?
No, Ranjit.
Okay.